Right, in this example, we're going to solve a quadratic equation that has two complex solutions. And let's just work through this. To solve this, we got to use the quadratic formula. So x is equal to the opposite of -1 is +1. -1 squared minus 4 times a, which is 1, times c, which is 2, all over 2 times a, which is 1. And then we simplify. Now at this point, it's good to explain to students that this number, after we square it, it's always going to be positive, because this means if it's negative, it means a negative multiplied twice, and we know a negative times a negative is a positive. So this is 1 minus 8, which is minus 7 over 2, but we know that this is the same as I times the square root of 7 over 2. Now again, just like the other examples, what we want to do is relate this to the function or the equation y equals x squared minus x plus 2. As we discussed in previous videos, when the solutions are imaginary, when we set, let me backtrack, when we set y equal to 0, we're finding the x-intercepts. If we get complex solutions, that means there aren't any x-intercepts, or in other words, the graph does not cross the x-axis. And if you graph this, the graph is going to look something kind of similar to that. And we see it never crosses the x-axis. It doesn't mean there's no solutions. There are solutions. There are zeros to this function, but there are no x-intercepts. So there's that fine line difference between x-intercepts and zeros. It has zeros. All the equations have zeros. It's just that sometimes these zeros are complex, and in such an example, that means it doesn't cross the x-axis, or it's not an actual x-intercept.